Hi everyone. This is an example of a solution stoichiometry problem that includes a precipitate. As always, we're going to follow our same 4 steps. We're going to navigate our way through the calculation in a new way. Here we go. Determine the mass of precipitate produced when 50.0 milliliters of 0.500 mole per liter calcium nitrate reacts with excess sodium sulfate. As always, our first step is balance the equation and interpret the question. We're on the lookout for some key words. We say that we're going to produce a precipitate. That's significant. We know that a precipitate is the solid product. And we have calcium nitrate reacts with sodium sulfate. A strategy is to focus on those words, focus on the chemicals themselves, or read the question and skip the numbers. Determine the mass of precipitate produced when calcium nitrate reacts with excess sodium sulfate. We need to do what we need to do to come up with the balanced chemical equation. That's our first step. Here we go. Calcium nitrate. Calcium is a 2+, nitrate is a 1-. Reacts with sodium sulfate. Sodium is a 1+, sulfate 2-. We have a double replacement reaction. The sodium and the calcium are going to exchange spots. The sodium gets together with the nitrate. And the calcium 2+ together with the sulfate 2-. We balance this reaction. Now we have 1 calcium on either side, 2 nitrates, 2 sodiums, and 1 sulfate. We continue our work. Determine the mass of the precipitate. What's the precipitate? The solid product. We have these 2 products. We need to go to the solubility table in the data booklet to decide which one is going to be solid. When we check the solubility, we find that it's the calcium sulfate that is the precipitate. So in an indirect way, this says determine the mass of the calcium sulfate produced. We have some givens. We have volume of concentration chemical. We've seen that formulation so many times. We have 50 milliliters of 0.500 calcium nitrate. Under the calcium nitrate, I'm going to get those labels in. The volume here is 50.0 milliliters. The concentration is 0.500 moles per liter. Wherever the question mark is, that's the R. The other set of numbers, the G. All of that is step 1. Balance the equation, interpret the question. Be on the lookout for those questions about a precipitate. We had to determine the solid product using the solubility table. Now we move on to step 2, find moles. It didn't tell us, we don't have a mass, we have to do C times V. We have it, concentration times volume. The concentration is 0.500 moles per liter. The volume, 50 milliliters, which we must convert to liters. Big reminder, all these volumes here must be liters. Take that 50, divide by 1,000. 0.0500 liters. Find moles, multiply by R over G. Here, R is 1, G 1. 1 over 1. And we're trying to determine the mass. If we were to stop right now, this early work and the R over G together, we've said it so many times, that's red N. Red N. After the R over G, we have the red N. We're looking for the mass. Mass is the red end multiplied by the molar mass. We're looking for the mass of calcium sulfate. So now here we're going to multiply by the molar mass of calcium sulfate. Let's calculate that. Calcium, the data booklet tells me, 40.08 plus 1 sulfur, 32.07 plus 4 oxygens, 16 times 4, that's 64. The molar mass of the calcium sulfate is 136.15 grams per mole. We have our calculation set up. Let's push buttons. 0.5, need to be careful here, times 0.0500 times 1 over 1 times 136.15. We get 3.4035. When we check our significant digits, 50.0, 0.500, that's 3 sig digs. We round this off appropriately. 3.40. We need some units here. We could follow the algebra of the units, or we could just remember that the mass is going to work out as grams. When we have a precipitate, it can come up in all kinds of different scenarios. Remember, it's the solid product. We have all kinds of different ways to navigate our way through these 4 steps, but we're always following those 4 steps. Don't forget to watch those significant digits and get those units in there. I hope that helps.